Hello advanced tutorable students and welcome back to another video lesson where we continue our exploration of quadratics, real numbers, imaginary and complex numbers, and slowly trying to figure out how we can quickly identify if a problem is going to have real solutions or imaginary solutions. So what I want to start with today is let's try and calculate the zeros by using the quadratic formula. Calculating the zeros is nothing more than trying to find the solutions, if it has any, where our graph would cross the x-axis. And so this first one, we have y equals x squared minus 4. And if we're going to use this quadratic formula, we do need to know that a is the value of 1, b is the value of 0, and c would be the value of negative 4. So identifying those so that we can plug them into here gives us this equation, 0 plus or minus the square root of 0 minus 4 times a times c. All right, so if we carry that on, we're going to get 0 plus or minus the square root. 0, negative 4 times 1 times negative 4 becomes positive 16 underneath, all over 2, which means we have plus or minus 4 all over 2. And if I solve that twice, 4 over 2, I get 2. Negative 4 over 2, I get negative 2. So we could say x equals 2 or negative 2 in that problem. And those are both real numbers. Didn't have to do anything with pulling a negative out. We didn't have to work on imaginary. So those are both real. Next one, we have a quadratic, y equals x squared minus 4x plus 4. Again, calculate the zeros using the quadratic formula. So in this problem, again, I'm going to start out by saying a is 1, b is negative 4, and c is 4. And then we'll plug that into the quadratic formula. Why don't you pause the video here, plug that in, and see what you get. All right, plugging it in. The opposite of b becomes positive 4 plus or minus. This b squared becomes 16 minus 4 times a times c, all over twice a, or we get 4 plus or minus the square root of 0, right? Because 16 minus 16 is 0, all over 2, which means we get 4 plus or minus 0 all over 2. So we don't really have to do it twice because 4 plus 0 is 4, 4 minus 0 is 4, and 4 over 2 would give us the answer of 2. Or here we could say x would equal 2. So this time we got one real answer, exactly 2. Previous slide, we got 2 real answers. Next one, calculate the zeros for y equals x squared plus 4. As you're noticing here, we got to find a, b, and c. A is 1, b is 0, c is 4. And when we plug that in to the quadratic formula, we should get 0 plus or minus the square root of 0 minus 4ac all over 2a, or 0 plus or minus the square root of negative 4 times 1 times 4 is negative 16 underneath that square root, all over 2. And as we learned last week, we can't do anything here till we take out the I value. I times the square root of 16 all over 2, or plus or minus 4i all over 2. So we've got positive 4i over 2, which is 2i. Or if we do that with the negative 4i over 2, we get negative 2i. So x could equal 2i or negative 2i. So we got 2 imaginary answers in our last example here. Now, if I go back, I want you to pay close attention to something that's happening in all of these problems and see if you can't figure out what might be the identifier. In this one, we got 0 plus or minus the square root of 16. So I had a positive value underneath the square root here, which then gave me 2 real answers, 2 or negative 2, right? 2 real answers. Whereas in our second example, when we evaluated, we had 4 plus or minus the square root of 0 over 2. Well, when we had the square root of 0, we got just one single real answer, one answer. The last one, we had 0 plus or minus the square root of a negative 16, which then gave us 2 imaginary numbers. This pattern of looking underneath the square root is actually called the discriminant. Discriminant. That b squared minus 4ac part. That's the part underneath the square root. It's called a discriminant, and it tells us the number and nature of the solutions. It tells us how many we might have. Anytime that b squared minus 4ac was greater than 0, or a positive value, we're going to have 2 real solutions, just like we saw in our first example. Anytime that value underneath is equal to 0, we're going to get 1 exact real solution. And then anytime it's less than 0 or a negative value, we are going to have 0 real solutions. We're probably going to get imaginary. And that's called a discriminant. And it just really tells us how many real answers we're going to get. So let's take a look at 3 different examples and try and figure out the nature of the roots and x-intercepts. The nature, how many real are we looking at? So remember, when we are looking at this discriminant, we're trying to determine the b squared minus 4ac, which is why I continued to try and find the b, the a, and the c. B squared is 2 squared minus 4 times a times c, or 4 minus, I'm going to do 5 times 4 is 20, times 6 is 120, 4 minus 120 equals negative 116. So we have no real solutions. We're probably going to have imaginary here. But the nature of these ones are no real solutions. We always speak about it in terms of real numbers. Letter B. B squared, which is 1, or 1 squared, minus 4a, which is 3, times c, which is negative 2. 1 squared is 1. Negative 4 times 3 is negative 12, and negative 12 times negative 4, or negative 2, becomes positive 24, which means we get a positive 25 for the discriminant, which means 2 real solutions. We're going to have 2 of them. And then in our last one, b squared, which negative 12, that quantity squared, minus 4 times a, which is 9, times c, which is 4. Negative 12 squared is 144, minus 36 times 4 is also 144, which gives us a final value of 0, meaning we would have 1 real solution. And so that discriminant, that b squared minus 4ac part, does indeed tell us the nature of our roots or our x-intercepts, if we'll have any, or if we'll have 2 or 1, or none at all. Now, the last example not only asks us to determine the number of roots, solutions, or x-intercepts, but then solve after we figured out how many. So take a minute and pause the video and trying to find the discriminant. Okay, again, you've got b squared minus 4ac for the discriminant. B squared becomes 3 squared minus 4 times A times C. 9 minus 12 times 8 is 96. 9 minus 96 is negative 87. Negative 87, which means no real solutions. We're going to have imaginary. And so let's plug this in. Because we have imaginary, we can't factor this. Factoring's not going to work. So we've got to plug it back into the quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac. But we already did that. That's right here. So I can put that negative 87 underneath right away because we already evaluated that. All over twice a, which is 2 times 3, or 6. So negative 3 plus or minus I times the square root of 87 all over 6 would represent our two answers. And again, we could write it twice by taking plus all over 6 and then a second one with a minus if we want to, but this is perfectly acceptable. So again, this is the intro where we're going to continue to build off of the discriminant theory here. If you have any questions, please make sure that you reach out and ask. Otherwise, until next time, everyone, stay safe.